The electrode connects to the amplifier via a lead. Collection of leads from multiple electrodes makes a cable. The lead is essentially a metallic wire, just like an antenna for radio or television. Hence, it also records the ambient noise and interference. Longer the lead, greater will be the voltage recorded by this antenna. Hence, the lead wires should be short. Insulated leads and cables will record less interference. The amplifier used by the electromyograph magnifies the difference in voltage at its inputs. If the ambient noise is similar at both inputs, their difference will be close to zero. Hence, it will have very low voltage at amplifier output. In contrast, if the noise appears different at the amplifier inputs, their difference will be magnified. This will give high voltage noise and interference at the amplifier output. Thus, the strategy to reduce noise is to make the noise at both amplifier inputs very similar. The electromagnetic radiation varies at different locations in the examination room. If the leads are away from each other, they will record different signals. If the leads are together, they will record very similar noise and it will be cancelled by the amplifier. This is done on some electrodes by interweaving the lead wires. In disposable electrodes or even in reusable electrodes, the lead wires may be separate. One can bring them together by tying a knot in their leads. In addition, long lead wires can be bunched together and placed under the tested limb for convenience. By confining the lead wires to the same small space, they will record very similar noise voltage that is attenuated by the differential amplifier. Perhaps the best strategy to reduce noise recorded by leads and cables is to reduce the ambient noise itself. Use incandescent lights instead of fluorescent lights. The fluorescent lights give much more electromagnetic radiation. Dimmer switches used to adjust illumination also give radiation. This is usually seen as sharp spikes at 2 times the power line frequency. Turn off the lights controlled by such a switch. All power cords behave like transmitters. Longer the cord, more will be the radiation. Hence, one should avoid using extension cords to power instruments. All electronic equipment emit radiation. Hence, all such instruments should be turned off when possible. As example, the electrically powered examination table. Even when it is turned off, the power cord of that device is still behaving as a transmitter. Ideally, one should unplug the power cord of unused systems from the wall outlet. Make sure that the system is properly grounded. The so-called ground or earth wire runs from the power outlet in the wall to a large metal pole that is buried outside the building in the ground. A good ground is needed not only for reducing noise, but also for the safe operation of the system. If you get a lot of power line frequency interference, you should get the integrity of the ground wire checked by a certified electrician. In nerve conduction studies, the stimulator leads should be kept away from the recording leads. Overlapping leads, as shown over here, often result in significant stimulus artifact. When constructing new facilities, the EMG laboratory should be housed away from facilities that generate strong electromagnetic radiation. For example, a radio or TV broadcasting station or radiology suite within the medical facility. In extreme situations, one can build a so-called Faraday cage. This involves remodeling of the wall and the ceiling. It is quite an expensive project.